Good day, everyone. In this video, I will present some known results on Lebesgue's outer measure. Now, recall that for the Lebesgue's outer measure, we have here the function m star from the power set of the set of real numbers to the closed interval from 0 to positive infinity. Now, take note that our function m star is always greater than or equal to 0 because we will be using that one later on. So the outer measure or the Lebesgue outer measure of the set A, where A is a subset of the power set of R, is equal to the infimum of the sum of the length of IN. Where we have this condition, the collection I sub n is an open cover of the set A. So I discussed that already in my previous lecture. What do we mean by the set of collection, or what do we mean by open cover? Now let's have here remark 1.2. For this remark, we have here, if we have here the countable collection of open intervals in which this collection is an open cover of A, then we have this one. Now we will be using the definition of the Lebesgue outer measure here. So because the Lebesgue outer measure of A is the infimum, and we all know when we say infimum, it means the value is smaller or equal to the values of the set. Follow? Recall that if we have here the set S, and if we say the infimum of S, here, infimum of S, say for example, infimum of S is always, say this is the infimum of S, we have here the set S, is always smaller or equal to the value in S. Say small s na siya ha. This is the element here in the set S. So always smaller. Therefore, this infimum here is less than or equal to this. Follow? Summation of the length of I sub n. Did you get it? So this one, the infimum is less than or equal to the summation of I sub n. This is I length of I sub n. Hence, the Lebesgue outer measure of A is less than or equal to the summation of the length of I sub n, where our I sub n here, the collection covers A. Now let's proceed to the next known result. We have here the Lebesgue outer measure of empty is 0. So the Lebesgue outer measure of empty is 0. So let's try to, I will try to discuss the proof of this proposition. So we will show this one, that the outer measure, Lebesgue outer measure, the Lebesgue outer measure of MT is 0. So of course, from the definition, we will try to get the collection that covers MT. So here, we let epsilon be greater than 0. And then, we let this collection, we use epsilon, that's why we let epsilon. So we will use epsilon in our collection. So we have this one. Say for example, we have, we have this as our collection that covers MT. Obviously, it covers MT. Why? Because we have, because this is the collection of this, or this is, shall I say, empty is a subset of this one, right? So empty, because we have here empty, is a subset of this one. So in that case, of course, this is a collection that covers empty. So it satisfies the condition. Then by remark 1.2, our previous remark, it states there that the Lebesgue outer measure of A is less than or equal to the summation of the length of the interval. Or since there is only one interval here, so we will not write any more summation. So we will just go directly to this open interval. So this is by remark 1.2, our previous remark. And out length, this is the length because that is the summation of the length. So the length of, and we know that the length of this is, of course, the absolute value of epsilon over 2 minus negative epsilon over 2. And of course, this is equal to 2. This is 2 epsilon over 2, which is equal to epsilon. That is epsilon. The Lebesgue outer measure of MT is less than or equal to epsilon. Take note that the outer measure of any set is greater than or equal to 0, as I discussed a while ago, right? So it should be greater than or equal to 0. Now, notice here that epsilon is any positive number. It could be very small. Here, the epsilon. And the Lebesgue outer measure of MT is less than any positive number. Epsilon. And it is greater than or equal to 0. Kumbaga, it is positive, but it is less than any positive number. So we are forced to make this 0. So we're done. Now let's have the next one. For our next proposition here, let's have the Lebesgue outer measure of the singleton set is equal to 0 for all x in R, or for all real number x. So to prove this one, we will use the same argument as this. So because what's this? By the way, let me have the proof of this. So here we will be showing that the Lebesgue outer measure of the singleton set is 0. So we will show the outer measure of this is equal to 0 for all real number x. So again, we will let epsilon greater than 0. So we let this one because we will be using this one in our collection of open covers. So we can let this one as our collection, as the open cover of, we can have x. We use x. So we have x minus epsilon over 2 to x plus epsilon over 2. So notice that this is an open cover of x. That is, we have this set x is a subset of or equal to this open interval. Okay, diba? In our definition, this set, if this collection is an open cover of this set, we have here yung A kanina, A. So it should be contained in the union of I sub n. So here, our I sub n here is this. We only have one interval. So because it is enough to cover our singleton set X. So minus epsilon. Okay. Now in this case, this collection is an open cover of the set X, so we can write it as this. So we will not write anymore the union because we only have one interval here, open interval. So again, by our previous remark 1.2, we can have the Lebesgue outer measure of this singleton set is less than or equal to what's that? The summation of the length of the interval. We only have one interval, so we can just get the length of this interval. Over 2. And we all know that this is equal to what? This is equal to epsilon. Why? Because we're going to subtract this one. So x minus x is 0. Epsilon over 2 minus negative epsilon over 2 is 2 epsilon over 2. And that is equal to epsilon. So we have now this one less than or equal to epsilon, but we know that the Lebesgue outer measure of any set is greater than or equal to 0. By the same argument, we are forced to say that the same argument as in our previous proposition, we can say that the Lebesgue outer measure of any singleton set is equal to 0 for any element in the real or any real number. So that's it. Now my next video is a continuation of this, where I am going to present and discuss the proof of some known results on Lebesgue's outer measure.